In this video, let's go ahead and practice a couple implicit differentiation problems together. Now, to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. For number one, let's go ahead and just take a look at the equation that we're starting off with. Now that we have the original equation, let's go ahead and differentiate both sides with respect to x. So on the left side, we're going to take d dx of the left side of the equation, and then we're going to go ahead and find d dx of the right side of the equation. Now on the left side of this equation, notice how we have three different terms. Let's just go ahead and find the derivative of each of these terms. So let's start with this negative xy. So let's go ahead and just leave the negative alone in front for just a moment, and let's go ahead and find the derivative of this xy using the product rule. So let's see, the derivative of x is just going to be 1 multiplied by y, so that's just going to be 1y or y. And then we're going to go ahead and add x multiplied by the derivative of y, which is going to be, let's see, just y prime. I'm going to write as y prime now, but I'll go ahead and turn that back into dy dx later. Next we have this y, so let's go ahead and find the derivative of that, and keep in mind, when we go ahead and take the derivative of y, we're always going to go ahead and write that we have this dy dx, but in this case I'm just going to write y prime for now. And then we have one more term here, we have this minus 4x to the third power, and if we go ahead and just use that power rule, we're going to get minus 12x to the second power. Finally, on the right side of the equation, if you take the derivative of a constant, like this negative 3, keep in mind that's always just going to be 0. So we go ahead and write that on the other side here. Now that we've gone ahead and found the derivative, let's see if we can find dy dx. Keep in mind that we're just using y prime right now for the moment, so let's go ahead and see if we can rearrange those. First, I'm going to go ahead and distribute the negative to both of these terms over here. And so if we go ahead and do that, let's see what we're going to get. Alright, now that we distributed the negative, let's go ahead and see if we can get these y primes together. Alright, so notice how these two terms here both have y prime, or that dy dx. Let's go ahead and see if we can move these other terms to the other side of the equation. So let's go ahead and rewrite this. On the left side, we're going to have this negative x y prime, and then we have plus this other y prime. So we're going to keep these on the left side of the equation. And then let's move everything else to the right side. If we're going to add the y to the other side, it's going to be y. And if we add a 12x squared to the other side, it's going to be plus 12x squared. We're adding both of those to the right side, along where that 0 was. All right, now if you look at these two terms on the left side, they definitely have this y prime in common. So factoring that out as a GCF, we can write y prime times the quantity of, and I guess we can go ahead and write this is going to be a negative x plus 1. Those are going to be its other factors here. And that's going to be equal to this y plus this 12x squared on the right side. All right, next let's go ahead and get this y prime alone. We can divide both sides by this negative x plus 1 power. So if we go ahead and do that, we're going to see it's going to be y prime, or actually at this point I'm going to change this to dy dx, since remember those are the same thing. That's the same thing as y prime. This is going to be equal to, on the right side we have this y plus 12x to the second power in the numerator, and that's going to be on top of this negative x plus 1 in the denominator. This right here would be our dy dx in terms of x and y. Alright, so hopefully you feel a little bit better now that we did an example problem together. If you want to go ahead and try this next one on your own, I encourage you to go ahead and pause the video and try it first. Or of course, if you just want to go ahead and do it together, we can do that too. Alright, so first things first, let's just go ahead and copy down the equation. So here is our original equation. Let's go ahead and start by differentiating both sides with respect to x. And that's going to look just like this, where we take d dx of the left side of the equation, as well as taking d dx of the right side of the equation. Alright, starting off with this first term of this negative 2y. If we go ahead and take the derivative of that, we're going to have this negative 2 and then dy dx. But for now, I'm just going to write y prime. But keep in mind that y prime is what we're looking for, that dy dx. Okay. Then we're going to take a look at the second term here. The second term is going to be this minus 4x to the second power. I'm going to go ahead and keep the minus sign here. And if we use the power rule, 4 times 2 is going to be 8. So we're looking at 8x raised to the first power. Go ahead and take away 1 from the 2. And then afterwards, let's see, we have a plus sign here, so I'm going to keep the plus sign. And then we have a product here, so make sure we take care of using the product rule here. So we could take the derivative of x, which is 1, and multiply that by y. So I'm going to go ahead, let's put this maybe in parentheses for now. So it's going to be 1 multiplied by y, or just y. and then it's going to be plus, and then let's see, the derivative of y, which is going to be y prime, or dy dx, multiplied by x. So I'm going to just keep this as x times y prime. If you want to pause and go ahead and write that out or think about it some more, feel free to do so. Okay. Next, if we go ahead and take the derivative of this 5 here, we're just going to have a minus, and the derivative of 5 is just going to be 0. I'm just going to go ahead and write it for now, just so I'm being very clear. And then finally, if you take a look at the right side, if we take the derivative of 0, which is another constant, that is also going to be 0. So we have a couple things that are going to cancel out here as well. And on the right side of the equation, we have this 0. So if you take the derivative again of a constant, just like that minus 5, we're going to get 0. Now there's an invisible 1 here. We can go ahead and distribute to both of these terms, or you can just go ahead and drop the parentheses. I'm just going to go ahead and rewrite that. All right, so here is our cleaned up equation a bit here. And just a reminder, we're going to be trying to get these y primes together, which is really just dy dx, so we can go ahead and find the derivative in terms of x and y. So we want to keep these two terms together so we can do what we did earlier in the last example, which is try to get the y primes together and then factor it out as a GCF. So let's go ahead and move this minus 8x and this plus y to the other side of the equation. So I'm going to go ahead and keep this minus 2 y prime, keep it on the left side. I'm going to keep this plus x y prime as well on the left side of the equation. If we go ahead and add 8x to both sides, it's going to be equal to 8x on the right side. If we take away y from both sides, it's going to say minus y on the right side of the equation. All right, so we really want to get this y prime alone, so we can go ahead and factor it out. If we factor out this y prime, it would be y prime times the quantity of this negative 2 plus x. Go ahead and factor it out as a common factor, and then don't do anything on the right side. We can just leave it alone as 8x minus y. Okay. Next, let's go ahead and get the y prime completely alone. We can go ahead and divide both sides by this negative 2 plus x. So dividing both sides by that, we're going to get y prime, and that's going to be equal to 8x minus y in the numerator. And this is going to be over this negative 2 plus x in the denominator. Okay. Now, if you want to go ahead and just rewrite this, keep in mind that we're looking for what? Dy dx, but y prime is the same thing. So we can go ahead and say that dy dx is going to be equal to this 8x minus y, again in the numerator, and then we have this negative 2 plus x in the denominator. So there you have two different practice problems dealing with implicit differentiation. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.